So for homework, you were to spin a penny 50 times and see how many times it came up tails. We're going to use Fathom to simulate this because obviously we wouldn't want to keep spinning pennies forever and ever. Um, Obviously, if a penny is fair, about half the times we would see heads and half the time we'd see tails when we spin it. So if you were to spin a penny 50 times, how many tails would you need to see to make you think the coin is not fair? Obviously 40 tails, I would think you'd be very suspicious. But what about 30 tails or 32 tails? Would that be enough to make you suspicious of the fairness of the penny? So to do this, we're going to start by creating a collection, and right now it's empty. So I'm going to create an attribute here called spin, and there are two outcomes, heads or tails. And what I'm going to do right now is I'm going to sample from this collection, and I've created a sample of 10 cases. You can see we've got a bunch of heads and tails in here, but you had to do this 50 times, so let's do this 50 times. I'll turn the animation off. With replacement basically means I can use this penny again and again and again. So let's do that. We sampled some more cases, and now you can see I've got a collection of 50 H's and T's in here for spinning my coin. And I could go through and by hand count up the number of heads and tails, but that would take a while. I could even take a look at a graph for the number of heads and tails. And I could do this again and again and see what's happening and try to decide if it's fair or not. But it'd be nice if we could actually count the number of times we see a tail occurring. So I'm going to collect a measure here, and I'll call it number of tails. So we're going to take a look at a count of the number of tails that we saw in our 50 spins of the coin. So this time we had 30. Let's do that again. And now we have 31. So it's changing depending on how many. Oh, now we've got 26. So the number of tails is not always 25. It might be 26, it might be 30, it might be 32. But we want to keep track of these. So we're going to collect some measures here. So we collected 5 measures, and let's take a look at what we've got here. Let's actually do a graph here of these measures. So here we have the number of tails was either 24, 25, or 21. And that's not enough to really see a pattern of what's going on. So let's do this again. We'll now collect 100 measures. And when I do that, I can start to see a pattern developing. Obviously 25 is what we'd expect to see in the long run on average if the coin is fair. So to see these numbers on either side of 25 isn't that unusual. Let's collect some more cases, or some more measures. Now we've got 200 flips, or spins I should say, 300 spins, 400 spins, 500 spins, and now this distribution of the number of tails is starting to look slightly resemblant of the normal distribution. Approximately normal, bell-shaped, symmetric. So how many flips would you have, or spins, showing up tails, would you have to be suspicious? Clearly 35 never happened in our simulation. That would make us suspicious of the coin. But 30, we shouldn't be suspicious. It's clearly very likely that 30 could be a possible outcome. Let's think about this as we look at your data that you collected for homework.